Hey everybody, this is Mary with another magical math moment. Today we are going to talk about simplifying expressions with rational exponents. So when we're talking about rational, we're talking about decimals that either are terminating or repeating. So something like 0.5 is 1/2. That's a terminating decimal. If you've got something like 0.3 repeating, which converts to 1/3, that's a repeating decimal. It goes on for 3 forever. So when we're talking about rational exponents, we're really talking about exponents that are fractions, which of course are one of students' favorite topics. These aren't that bad though. So let's say you have something like x to the m over n. That exponent on top is going to be your inside exponent when you rewrite it as a radical. The n is going to go on the outside. We call this the index or the root. So if we were to rewrite x to the m over n as a radical, it's the same thing as the nth root of x to the n. We can also convert that over to the nth root of x being raised to the m power. So we can go ahead and just kind of pull that out. That's a property of radicals. So let's say we've got something like 27 to the 4/3. That is the same thing as the cube root of 27 to the 4th. The cube root of 27 is 3. 3 to the 4th is 81. Your graphing calculator will also do this for you, but it is important for you to have an understanding of how this works. So if you just go to your calculator and type in 27 to the 4/3, it'll tell you the answer, 81. Pretty cool. Another part of this has to do with negative exponents. So let's pretend for a minute we have something like 2 to the -3. Remember that that's the same thing as 2 to the -3 over 1. And so we're going to take that 2 to the -3 and move it down to the denominator and change the power positive. So it goes up from up to down. And then we just evaluate 2 to the 3rd. So this is 1/8. There'll be some equations that you need to solve as well, and you can do that by taking the nth root. So for example, let's say you have something like x to the 4th equals 81. To kind of undo this exponent, we're going to take the 4th root of both sides. So we've got x equals 3. Since this is an even root, I do have to put plus or minus here. So be mindful of that. Another example may include a binomial. So you might have something like x plus 1 to the, let's do 3rd, is equal to -50. Why not, right? So we are going to get rid of this cubed by taking the cube root of both sides. The cube root and the cube are inverse operations, so they kind of cancel out. So now we're left with x plus 1. This is where it gets weird when you've got an odd root or index here, okay? We've got -50 inside. Hopefully you all agree that that's the same thing as the cube root of -1 times 50. I can then further split that up into the cube root of -1 times the cube root of 50. The cube root of -1 is just -1. The cube root of 50 is not going to break down into anything, so we're going to go ahead and leave it alone. I am then going to solve for x by subtracting 1 on both sides. So I end up with -1 minus the cube root of 50. If you want to leave that -1 in front, you can totally do that. For our purposes in Algebra 2 Honors, we like to leave things like this in simplified radical form. Sometimes the textbook might ask you to give a decimal for this. So to get the cube root on the calculator, you're going to go to the Math button and then scroll down to number 4 for cube root. See how it pops it up there for you real nice? But let's put the whole expression in here. -1 minus the cube root of, what was it, 50. -4.68. So again, since we're estimating, we'll use our little approximately symbol, and that would be your approximation. I hope that this was helpful for you, and I look forward to having you back for another magical math moment. Bye.